So basically, for the law of cosines, you're going to need a triangle. Just for clarity, this is not a right triangle. There are other, better, faster things that we use to solve for right triangles, right? Pythagorean theorem, regular trig, inverse trig. Those all work on right triangles, and they're better and faster, okay? So if you get a triangle and it's not a right triangle, then you're either going to use law of sines on it or law of cosines, okay? So let's label the vertices A, B, and C. Why? Because that's what the formula uses. It uses capitals for the vertices, and it uses lowercase for the sides opposite. So opposite vertex A is side A, and opposite B is side B, and opposite vertex C is side C. And there are 3 equations. I'm just going to write one of them, okay? So I'm going to say that C squared is equal to A squared plus B squared. We've seen that before, right? Mm-hmm. Okay. Minus 2AB times the cosine of C. Okay. So all of the lowercase in here are all sides. So C is a side, A is a side, B is a side, A is a side, and B is a side. The only capital letter in here is this C right here. That's the angle, okay? The other 2 equations start with B squared and A squared. It just depends which of the, what you're solving for is which one you should use. But they're basically all 3 the same, okay? All right, so let's look at an example of how to use it. You okay?
Yeah.
Okay. Bless you. Thank you. All right, so for example 1, we're given 3 pieces of information. So let's draw a triangle. Non-specific right, non-right triangle. We'll label the vertices A, B, and C. And then opposite vertex A is going to be side A, which is 10. If it's 10 centimeters, write 10 centimeters or 10 inches, whatever. Okay, opposite angle B is side B, which is 13. And then angle C is 70 degrees. We are going to find little letter C. I'm going to put little letter C over there. Okay, so sometimes the triangle's already drawn for you, the information's already there. If not, draw one, label it the best you can, and then decide which of the 3 formulas you're going to use. Because we're solving for C, we're going to use that one I just gave you, the C squared. So we're going to use C squared equals the A squared plus the B squared minus the 2AB times the cosine of C. So C is what we want to find. So we're just going to say C squared equals, and then A squared, we're going to plug in 10, so we'll have 10 squared. B squared, we have 13, so we're going to plug in 13 squared, minus 2 times the 2 numbers I just plugged in, the 10 and the 13, and then the cosine of C, so the cosine of 70 degrees. Yes, sir?
It wouldn't be inverse cosine, right? That's only when...
No, not that's if you're finding an angle. The angle here is given. Okay. All right, so from here you just want to simplify, right? Calculator can do most of it for you, but some of it you'll be able to do in your head. So 10 squared is 100, 13 squared is 169, minus 2 times 10 times 13 all happens to be 260 times the cosine of 70. We'll plug that in the calculator in just a second. So 100 plus 169 is 269 minus, and then you just want to punch this part in the calculator. I mean, you could have done other parts in the calculator up to this point, but I mostly did that much in my head. Okay, so I'm going to do 260 times the cosine of 70. That part you probably can't do in your head unless you've memorized a chart. So do it, bless you, do it on a calculator, and it's going to get you this decimal. Let's round it to the nearest hundredth. So right now I have 88.92, but there's a 5 next to it, so I'm going to go 88.93. And then for c squared, I'm going to subtract that. So I'm going to say 269 minus, and then the previous answer should still be in there. I've got 180.07. There's a 4 next to it, so it stays. So 180.07. And I want to get C, so I do what to both sides? Square root. Okay. So just leave that answer in there, right? And go second square root, second answer. Hit the equal sign and it gets it for you again. So 13.41, but there's a 9 next to it, so we're going to round. I'm definitely going to use the wavy equal sign. And 13.41, but there's a 9 next to it, so 42. And that's how you do one. All right? Any questions on example number 1? We're good? All right, let's do one where instead of finding a side, you're going to find an angle. Okay? So this is example number 2. Bless you. We've got 50 meters, 120 meters, 150 meters. We want to find the largest angle and we'll go to the nearest tenth again. Okay. All right, so let's draw a triangle. And again, not a right triangle, it's random non-right triangle. Label the sides 50 meters, 120, and 150. The directions say to find the largest angle. How do you know which one's the largest? Do you guys remember the little trick from geometry?
The largest side, or the longest side, has the largest angle opposite.
Right? So if this is the longest side, then you go to the opposite. This is going to be the largest angle. Okay? And we can use whichever of the 3 formulas that we'd like. I mean, c squared is always the easiest one because it's a squared plus b squared, and most of like you have that in your brain. But would you guys like to use a or b? Or do you want to use c? C. Okay, let's use c. So we'll call that angle c, and then a and b. We're just getting this angle. I'm pointing to nothing. We're just getting that angle.
So it doesn't matter which one you label, like A, B, C.
No, the three formulas are the same. It's just rotating between the three angles. Okay, so again, we're going to use the c squared, a squared plus b squared minus 2ab times the cosine of c. Okay, so this c squared is 150 squared equals, we'll go with, this is our a, this is our b, so 120 squared plus 50 squared minus 2 times 120 times 50. And then the cosine of c is what we want to find. Okay? So whereas in the last problem we used regular trig, on this one we're going to use inverse trig. Because in the end we're getting an angle measure. Okay? So for the rest of it, just use your calculator, right? 150 squared, I got 22,500. 120 squared is 144,000. And 50 squared is 2,500. Minus, and then 2 times 120 times 50, I got, what did I get? 12,000. All that times the cosine of c. Okay, so I can actually combine these two, right? 144,000 and 25,000 is 169,000. No, 16,900. So I'm going to actually, well, let me write one more step first. So I'm going to subtract that 16,900 from both sides. That leaves me with 5,600. And then I've got negative 12,000 times the cosine of c. Okay? So I'm going to actually, here, bless you, for this step, now it's being multiplied. So I'm going to divide by negative 12,000. That's going to give you a negative, and it's going to give you a decimal, right? Bless you. Wow. And you can do it on the calculator if you like. Let me move it over here so you can see it. So 5,600 divided by, and you can use the negative symbol if you want. It's just going to make it come out negative. So 12, 1, let me make sure I get the right amount of zeros. Okay. Equals, and you've got a negative number and it's a decimal. You can write it down if you want to. I'm just going to put a 6 with a bar. Because on the right, that leaves me with the cosine of c. Okay? That means in order to get c, I'm going to do the inverse cosine of this. Negative 0.46 with a bar. But I'm not going to retype all that in the calculator because that's a lot of punching and memorizing numbers, right? So I'm just going to go second inverse cosine, make sure you have a little negative 1 up there, and then go second answer. It's going to put it in there for you. Don't like sit there and punch a bunch of 6s, okay? Hit the equal sign, and that tells you that that angle, let's round it to the nearest whole number in this case. So we've got 117, but there's an 8 after the decimal, so we'll go with 100. Oh, no, it said tenths. Okay, so we'll do 117.8. All right, any questions on example number 2 there?